right, so this is going to be section 9.7, and these are, we call these special products. And what we did yesterday, we had the notes, but there were two things that we did. All right, two special products, they're called. One was the difference of two squares. If you didn't take notes yesterday, as you may want to take them today. And if you recall, if we did something like x minus 3x plus 3, and you were to use FOIL, you would get x squared plus 3x minus 3x minus 9. And these two terms would cancel out. And we're left with x squared minus 9. You'd have a positive 3x and a negative 3x. And so this is the difference of two perfect squares. X times x, 3 times 3. Well, now we want to go from something that's a perfect square, like, for instance, x squared minus 25. X times x is x squared. 5 times 5 is 25. And we want to go to factor that. And the way that it factors, you have the x, and you have 5 and 5. And one's positive and one's negative. Okay, and that's what we did yesterday, looking for the difference of two perfect squares. Right? Now, if this equaled 0, we can just carry that down. And so if you were to solve this equation that you had to do in a couple of problems, your answer would be a positive 5 and a negative 5. Okay? Because x minus 5 could equal 0, or x plus 5 could equal 0. So that's your two values. The other, let me just give you another example. Another example of this might be, let's take 24x squared minus, let's see, (216) y squared. I don't know if this one's going to work or not. No, this one won't work. All right, so let's try something maybe a little bit simpler. Let's take 3x squared minus 27y squared. Okay? And whenever we factor, we always look to see if the terms have anything in common. And they do. They're both divisible by 3. So if we factor out a 3, then I have x squared minus 9y squared. And I have the difference of two perfect squares. X times x, 3y times 3y. So now I can factor it as x minus 3y and x plus 3y. Okay? Now you notice we didn't put this one equal to 0 because I've got two variables there, an x and a y. So we can't set this one equal to 0, but we can factor. And that's one of the ways that we factor. That was one of the special products, the difference of two squares. Okay, question?
That one, the difference of two squares will always have two answers?
There's no answers. Yes.
Well, when you solve for
Yes,
zero.
when you solve for x, there's going to be two answers. Okay? One will be positive and one will be negative. Then we had something that was a perfect square trinomial. And that might look like x squared plus 10x plus 25. Now, if you look at the first term, excuse me, the first term, which is x times x, and you look at the last term, which is 5 times 5, maybe it will factor this way. Maybe. But what you have to do is you have to check to make sure I can get 10x. And the way we check, using that three-step process we talked about, 5 times x, multiply terms together, it's 5x, and double it. Do I get the middle term? Yes. 5 times x is 5x. When you double it, you get 10x. So it works. And you could test it out if you wanted to. You could multiply x plus 5 times x plus 5 just to see. Now, if this equals 0, how many answers are we going to have? One answer here. Okay? It's actually called a double. And the answer would be whatever makes this equation equal to 0, and you subtract 5 from each side. And so x equals -5. Maybe you'll get something where you have x squared minus 12x plus 36. Can that be factored this way? If you look at the first term, it's x times x. If you look at the last term, it is 6 times 6. So maybe it'll factor with the x here and the 6 there. And what about that middle sign? What about the sign? It's going to be negative. Now, if I multiply x times x, I'll get the first term. If I multiply 6 times 6, I'll get the last term. To check for the middle term, multiply the two together. You get -6x. Double it. We get -12x, right? Okay. So that works. And basically, that's what we did yesterday. All right, this is section 9.7. Now, what I'll do now is I'll have you guys ask me questions on your homework from yesterday. Your homework from yesterday, let's go back to this screen. Your homework from yesterday, Emily, was what?
Page 603, 430.
We did page 603, we did 4 through 30, and we did the even problem. So it was about 13 problems I had you guys working on. And that was the lesson from Thursday. All right, Thursday, April 19th. Yeah, okay. Now I'll answer some of the questions you might have. And Ozzy, what was your question? 14, okay. This is 14. Read it.
2x squared plus 12xy plus 18y squared.
Okay. Now, look at the variables, the x and y. Is there something that each one of those three terms have anything in common?
Divisible by 2.
Okay, divisible by 2. But no variables. This one has an x, this one has an x, but this one does not. All right, so I can't take out any variables, x or y, but I can take out a 2. So that's what I want to do first. Remember what I said. You always want to do that first. Take out the greatest common factor. Yes. For right now. Yes. And so this is x squared plus 6xy plus 9y squared. Did you get that, Ozzy? Okay. Now, what Kristen just asked me is that you only look at the two outside numbers? Yes. Can you put the two parentheses there and guess and check it? Yes, that will work. That will work. However, maybe because x times x is x squared, and 3y times 3y is 9y squared, maybe it will factor. Does that make sense, Ozzy?
Yeah, that makes sense, but then what about the x?
Go ahead. What about the?
The x, because you times it together, you get 3y x.
All right, when you multiply them together, you get 3xy,
And then you double it.
and then you double it, and you're going to get 6xy, right? Okay, so you can't forget that step. Your question was probably, how do you get that middle term?
Yeah.
Yeah. Okay. All right. Sydney?
We do number 8.
All right, number 8. What's that?
25x squared minus 144y squared.
Do you know of, now we have two terms and it's subtraction. So we have the difference. Can it be the difference of two perfect squares? Is 144 a perfect square?
Yes.
Yes, 12 times 12. Is 225 a perfect square?
Yes.
It is. And if you don't know what it is, what I want you to do is, if you don't know what times what is 225, what you can do is go to your calculator. Every calculator has this, so if you have a simpler calculator at home, you go to your square root function. You know how to get there? It's, you hit the second function and your x squared, your second x squared. It's in the first column, about 5 buttons down. You have that symbol?
Yeah.
And you just put 225, close that parenthesis, and the square root of 225 is 15. That means 15 times 15 is 225. Okay? So then I can write this as 15x minus 12y times 15x plus 12y. Now there's another way to do this problem. Yeah. Go ahead, Eric. What?
Like the answer, to get the answer,
Mm-hmm.
15xy minus, or 15x minus 12y squared.
No, you can't do that because you have one has to be positive, one has to be negative. All right. However, there's another way to do this problem. Can anybody think of it? Yes.
Maybe factor something out.
Yeah. Very good, Sid. Maybe factor something out. What goes into both? You know? Do you know?
3.
3. Zach, you're right. 3 does go into both. But is that the biggest number that goes into both? Do you know what else goes into both? And this one's hard to see. But 9 goes into both. And watch if we took a 9 out. Let's do this problem again. If you factor a 9 out, think of this as $2.25. 9 times what is 225? Think of it as money. 25, yeah, because 9 quarters is 225. Right? Okay, and so we have, it would be 9 times 25x squared minus, and 9 goes into 144, 16. So we can also factor this way, 5x minus, not 8, 4. And then 5x plus 4y. And I will tell you this, you know, and either answer for right now would be acceptable. But I will tell you this, there is only one way to factor these problems. I know you're seeing 2 ways here, but they're both, essentially they're both the same. Okay, but there's not, well, could it be this one or this one and have it different? No, there's only one factor
So
for
we
each
could
one.
do either way.
Either way. Okay. Do we have any other questions on our assignment from yesterday? Yes. 30? Could you read it for me, please? Go ahead, Summer, read it.
Negative 2h minus 3 minus 9k 0.
Here. We want to solve the equation. So solve the equation. What does h equal to? Okay. When you have a negative, we want to factor that out. When it starts with a negative, right? And what else do they have in common, Kristen? Yeah, they're all divisible by 2, so we're going to factor out a negative 2. Make sense? Now I'm going to have h squared minus 14h minus 40. Oh, that's plus 14h. And then plus 49 equals 0. Follow so far? Yeah. No, not plus 28. It'd be plus 14. A negative 2 times a positive 14 gives you the negative 28. Okay? So now I have negative 2. And let's see if it factors this way. H squared is h times h. So we'll put that right there. What times what is 49? Kristen? 7. Do you think my sign is going to be positive or negative? And do you get the middle term? When you multiply the two together, you get 7h. And double it, you get that middle term of 14h, don't you? When you multiply these two together, 7 times h, you get 7h. And then if you double it, you get 14h. So that's how we factor. So what does h equal then? Kristen? All right. Well, the negative 2 can't equal 0, so we don't have to worry about that. And then in parentheses, what would make h plus 7 equal to 0? So we subtract 7 from each side. So h could equal negative 7. Pardon? You leave the negative 2 outside, because negative 2 cannot equal 0, so we don't need that actually. Okay? Yes, Jack.
Why do you just get rid of it though?
You don't get rid of it. You know, do you remember that? You remember that you could have negative 2, either this one equals 0, or this equals 0. Well, negative 2 can't equal 0, so this really doesn't come into play. If it were a negative 2h equals 0, then h would equal 0. But we don't have that situation. Okay. Pardon? You don't? No, there's nothing to do with it. Okay? Yes. Yes. All right, let's take a look at number 20. Read that for me, Colin.
45 r squared minus 120 rs plus 80s
80?
s.
Okay. Can you tell me what number goes into all three terms? All right. So we take a 5 out. Does it equal 0? Oh, no, it can't equal 0 on this one. All right, and we have 9r squared. Is that a perfect square? 3r times 3r? Okay. 5 goes into 120. How many times? And 5 goes into 80? 16. Did you have those numbers?
You know, I had 17.
Okay. Well, just to finish this up, 9r squared is a perfect square. 16s squared is a perfect square. Maybe it'll factor as 3r. 9r squared, right, would be 3r times 3r. 16s squared would be 4s times 4s. Maybe it'll factor this way. My middle sign would be negative. If you multiplied 3r times 4s, you get negative 12rs, correct? Double it. Negative 20. So you get that middle term, you're done. Okay? Yes,
Are you gonna read the answers to the rest of them?
I will. Any questions? All right. For your homework for tonight, I'd like you to do on page 603, 604, actually, why don't we do this? Why don't we do,
That sounds good.
we'll do 3 through 23, and then we will do make it 3 through 29 odd, and then I want you to do 32 through 38 even. All right, and I want to do one of those problems for you down near the bottom because they are a little tougher. No, you know what? I think you can handle those. I think you can handle those.